Hey everyone, welcome back. Ready to dive into some serious coding concepts today. We're tackling design patterns, specifically the decorator pattern in C++N.
Decorator pattern. Sounds kind of fancy, right?
It does. We actually have some slides from a C++ presentation that we're going to be using as our guide today. And get this, they're originally in Spanish. But don't worry, we've translated them just for you.
Sí, claro. It's true, these slides are great. They actually make it a lot less intimidating than it sounds.
Yeah, they seem really thorough.
Yeah.
So no need to be scared off by the C++ or the design patterns part. Although, speaking of, can we maybe start there? For those of us who maybe haven't encountered this before, what exactly is the decorator pattern?
So in essence, it's a way to add features to your code, to your objects, specifically without having to create a whole new subclass for every single variation.
Okay, that already sounds pretty useful.
Hmm.
But I'm still picturing like a physical decorator, like someone who comes in and redecorates your house.
Right, yeah. It's not a million miles away from that, actually. Instead of redecorating a house, though, imagine you're, say, making a cup of coffee.
I can get behind that analogy.
The decorator pattern lets you add stuff to your coffee, milk, sugar, you name it, without actually changing the fact that it's still coffee at its core.
Okay, I think I'm starting to get it. So instead of making a whole new cup of coffee every time I want to add something, I can just like enhance the original.
Exactly. And the best part is it keeps your code super flexible. In fact, one of the slides actually calls out this idea of building more complex objects as a key takeaway.
Oh, that's interesting. And speaking of the slides, there's one here with a diagram that looks surprisingly like a coffee shop order gone wrong. Can you maybe walk us through it? What are we looking at here?
Sure, yeah. So up at the top, you have the component. That's like the basic blueprint for your object. It defines the most basic stuff it can do.
So if the component is like a blueprint, what's the concrete component that's also on this diagram?
Good question. That's like a specific instance of that blueprint. Think of it this way. If the component is like, say, a car in general, then the concrete component would be like a red convertible.
Okay, yeah, that makes sense. Now, where do the decorators come in?
So decorators also inherit from that component blueprint. That means they can basically be used in place of the concrete component. But here's where things get interesting. Decorators are kind of like wrappers. They hold on to a component and then add to its capabilities without changing the original design.
Wait, so they're adding on to the original without changing it. That's pretty cool. I'm guessing those concrete decorators at the bottom of the diagram are those actual add-ons?
Exactly. Think of it like this. If our concrete component is a red convertible, a concrete decorator might be a sunroof. It adds a new feature, but the car underneath is still a red convertible.
Okay, this is making a lot more sense now. So you're telling me I can add a sunroof, then maybe some fancy leather seats, and then top it off with an amazing sound system, and it's all still anchored to that original red convertible.
Yeah, that's the beauty of it. You can stack these decorators, and each one adds a new layer of functionality without you having to create a whole new car, so to speak, every time.
Okay, you've officially sold me on the concept. This sounds way more flexible than I thought, but how does this actually look in practice?
Yeah, so there are actually a couple of slides that show some C++ code. Don't worry, I don't think we need to get into like line-by-line analysis.
Yeah, let's save the coding boot camp for another day.
Yeah,
But maybe you could give us the like Spark Notes version, just so we can see how this actually works in the code.
absolutely. Okay, so remember our component class. Let's say that's our car, right? And like any good car, it's going to have a drive method.
Okay, makes sense. A method is like what? A function? Something the car can do?
You got it. So now let's say we want to soup up our car a little. Add a turbocharger.
Oh, now you're speaking my language.
In that case, we'd create a new class. And we'd call it, you guessed it, turbocharger decorator.
Yeah.
But, and this is important, this new class would still inherit from that original component class.
So it's still a car. It can still drive.
Exactly. But here's the cool part. The turbocharger decorator would also hold on to like a reference to that original component object.
So it's like attached to the original car, not replacing it entirely.
Perfect analogy. You're getting it. So now when our code calls that drive method on our turbocharged version, it first calls the drive method of the original car.
To make sure it can still, drive.
Exactly. And then, and this is where the magic happens, it layers on that turbocharged boost.
Oh, that's pretty slick.
Yeah.
So if we wanted to then add, like those leather seats we talked about, we'd create another decorator, right? A
Yeah.
leather seats decorator.
You got it. And that leather seats decorator would also call that base drive method again, making sure the car can still function like a car, and then it would add its own special touch.
This is amazing. So we can keep adding these layers, these decorators, and it just keeps getting more and more customized.
Precisely. And that flexibility is one of the big things they highlight on, let me see, yeah, right here on this slide. It talks about adding functionality dynamically.
Dynamically. Does that mean, like, I could be driving down the highway and suddenly, boom, leather seats?
Haha, maybe not quite that dramatic. Dynamically in this sense just means that we can add or remove these decorators while the program is running. We don't have to like completely rebuild the thing every time we want to make a change.
Okay, so maybe not as exciting as a mid-drive makeover, but still really cool.
Oh, and there's another benefit listed here, avoiding class explosion.
Class explosion sounds messy.
It can be. Imagine if you had to create a separate class for every single possible combination of features a car could have.
Yeah, that sounds like a coding nightmare.
Exactly. The decorator pattern saves us from that by letting us mix and match these decorators however we want.
It's kind of like, okay, imagine you're at a burger place, right?
Right. I like where this is going.
You have your basic burger, your component,
Mm.
and then you can add whatever toppings you want your decorators without them having to create a separate menu item for every single combination.
Perfect analogy. It keeps things clean, organized, and way easier to manage.
Okay, you've convinced me.
Yeah.
This pattern is officially on my to-learn list. Although speaking of food, one of these slides has a coffee shop example that I have a feeling is right up your alley.
Oh, I'm always down for a good coffee break. What does it say?
Okay, so this slide is all about, well, coffee. They set up this scenario like you're at a coffee shop.
Sounds familiar? What'll it be?
Let's see, I'm feeling a latte today, so I guess that's my concrete component,
Yeah,
the base for my coffee masterpiece.
good choice. And what are we adding to that masterpiece today? A shot of caramel, some whipped cream.
Ooh, you know what? Let's go with a sprinkle of cinnamon. It's feeling like a cinnamon kind of day. But, okay, how does that actually work in, like, decorator pattern terms?
Okay, so think about how you make a latte. You're steaming milk, adding it to espresso.
Right.
That's your latte's like prepare coffee method. Adding the cinnamon, that's like using a cinnamon decorator. It would take your latte, run that prepare coffee method, and then boom, sprinkle that cinnamon right on top.
So it's enhancing, not replacing.
Exactly. It's like adding an extra layer of deliciousness without messing with the latte itself.
I'm into it. Although, okay, what if I change my mind at the last second? Like, right as you're about to sprinkle the cinnamon, I'm like, wait, no cinnamon? Do we have to start over from scratch?
Nope. That's the beauty of the decorator pattern. Remember how we talked about it being dynamic? We could just like remove that cinnamon decorator and our code would know, okay, latte, no cinnamon.
That is way more sophisticated than I ever would have guessed. I
Mhm.
mean, I just thought they, like, memorized my order or something.
Uh-huh. Maybe some do. But yeah, this pattern, it's often working behind the scenes, making sure things run smoothly without us even realizing it.
So we've covered cars, coffee, even burger joints. Where else might someone find this decorator pattern in action?
Seriously, you'll see it everywhere once you start looking. Like, think about customizing a pizza with toppings. That's decorator pattern. Or adding filters to a photo. Also decorator pattern. You're essentially starting with the base and then layering on these extra features.
Well, my mind is officially blown. You've given me a whole new way of looking at, well, everything.
Glad to hear it. Hopefully next time you're designing something, whether it's code or like your actual dream home, you'll think about the decorator pattern, where you really can help you create some amazing things.
Absolutely. And on that note, I think I'm going to go grab myself a latte. Until next time, everyone, happy coding.